than a century, bicycles have stopped the very same way. Rubber pressing hard against metal. It works, but slowly, it wears away. In the rain, it slips. On steep roads, it screeches. Every rider has felt that sudden loss of grip, or heard that piercing squeal echo on the street. Friction brakes are noisy, they wear out, and they fail when conditions are toughest. But what if there was another way? A way to stop smoothly, silently, reliably, without a single piece of rubber touching the wheel. This is not science fiction. It is real, and it begins right here. What looks like magic is actually one of the most fundamental laws of physics. It's called Lenz's law. When a magnet moves close to a conductor like aluminum, it creates swirling whirlpools of electricity inside the metal. We call them eddy currents. And these invisible currents fight back. They create their own magnetic field, one that pushes against the magnet itself. The result is resistance. Motion slows down. No contact, no grinding, just pure physics, turning invisible forces into stopping power. To bring this law to life, we started with a simple test. A spinning aluminum plate, set in motion. Then, a strong neodymium magnet, brought close to its edge. Watch what happens. The plate slows, suddenly, almost as if an invisible hand is holding it back. No contact, no wear, no sparks. This is the power of eddy currents in action. A moving magnet, creating resistance in a conductor, converting motion into heatless drag. In this moment, what seems impossible becomes real, stopping motion, without ever touching it. But the question remained, could this invisible force be scaled up, to stop a real bicycle wheel? We built a wooden frame, sturdy enough to hold the wheel. Then we mounted a set of strong neodymium magnets, onto a lever arm. First, we set the wheel spinning freely. With the magnets pulled away, there is no resistance. The wheel turns smoothly, almost effortless. Now watch closely. The lever moves, the magnets glide closer to the rim. Instantly, the wheel begins to slow. No squealing rubber, no grinding pads, just a silent, controlled stop, powered entirely by magnetic force. Side by side, the difference becomes clear. Traditional brakes rely on friction, rubber pads grinding against metal discs. It works, but over time the pads wear down, parts need replacing, and in wet or muddy weather, performance drops. Now compare that to magnetic braking. No contact, no wear. The rim remains untouched, the system stays clean, and performance is the same whether it's dry, raining, or snowing. One is noisy, wearing, and weather dependent. The other, silent, smooth, and reliable. A true leap forward in how we think about stopping a bicycle. Traditional brakes waste rubber with every stop, pads wear down, get replaced, and end up as landfill. This also reduces efficiency and stresses the wheel over time, making braking less reliable. Magnetic braking solves it all. No friction, no wear. The bike stays smoother, safer, and performs the same in rain or shine. Less waste, more confidence. That's the future of braking. Silent, clean, and reliable, magnetic braking isn't just an idea, it's the future of cycling.